Hello and welcome to this Edexcel Further Math Statistics 1 video looking at the probability generating function for a linear transformation of a variable. So this slide looks again at the example we looked at in the previous video of a spinner, and we have the probability distribution of x here, the outcomes possible and the probability of each outcome. And we discovered in the previous video that the expected value for x, or the mean of x, is 1.5. Now what if we do a transformation for x, and rather than considering the expected value for x, the score on the spinner, we look at the score as 3 times the value of x plus 1. What would the expected value for 3x plus 1 be? And you should recall from previous work on expectation that that is 3 multiplied by the expected value of x plus 1, which would be 3 multiplied by 1.5 plus 1, which is 5.5. Alternatively, you can consider, rather than x, actually the outcomes 3x plus 1 in each case, which would be 1, 4, 7 and 10. And then we can simply work out by multiplying each of those by the probability with which they occur. We can then work out the expected value of 3x plus 1 directly, and that would actually give us 22 over 4, which of course is also equal to 5.5. We're going to have a look now and see how a probability generating function is affected when we look at a linear transformation for a random variable. So for our discrete random variable x, this is our definition for the generating function e of t to the x, which is this summation here. Remember that summation is over all the possible outcomes for x. So what would the generating function be for 3x plus 1? And going from the definition at the top of this slide, rather than e t to the x, we want e t to the 3x plus 1, and that would be the sum over all possible outcomes for x, not of just t to the x, but t to the 3x plus 1, multiplied by the probability our random variable takes the particular outcome involved. And we can think about this summation and simplify it a bit by writing t to the 3x plus 1 as t to the 3x multiplied by t to the 1 multiplied by px equals x, and then because we're summing over x, the t has no x involved in it, so that can be taken out of the summation, and we simply end up with t to the 3x multiplied by the probability our random variable takes the particular value, and that can be regarded as t cubed to the power x. T to the 3x is t cubed to the power x using rules of indices, multiplied by the probability our random variable takes that outcome. So how could we simplify that and generalize it? Now this slide summarizes what we did on the previous one, and the fact that we discovered that the probability generating function of 3x plus 1, which is the expected value of t to the power 3x plus 1, can be written as t multiplied by what looks like the expression for a generating function, but rather than having t to the x, we have t cubed to the x. And therefore we could say the generating function of the linear transformation of x to 3x plus 1 is t, from the t that multiplies the summation here, multiplied by the original generating function, but instead of t being the variable involved, we have t cubed being the dummy variable. And generalizing that, you have seen from what we did before that the generating function of 3x plus 1 is t to the 1 multiplied by the summation of t cubed to the power x multiplied by the probability the random variable takes that particular value of x. And so if we have a general transformation where we have ax plus b, we would have t to the b multiplied by our generating function, but instead of just t, it's in terms of t to the power a. And writing that slightly more simply, the generating function of a linear transformation of x to ax plus b would be t to the b, so the constant term there, and the coefficient of x tells us the power of t that's now involved in the generating function, rather than just the generating function being of t. So let's now look at an example. So we have a generating function, and we're going to look at how to find the generating function for a linear transformation. So here we have our generating function for x. What would it be for 3x plus 1? And you need to remember the result that we found, that the generating function for a linear transformation of x to ax plus b is t to the b multiplied by the original generating function, but with t to the power a as our dummy variable, not t. So using that with this example here, 3x plus 1, it would be t to the 1 multiplied by our original generating function, but with t cubed substituted in for t. And this is written out here for you, so you can see that we originally had t, we've now got t cubed. We originally had t squared, we now have t cubed squared. And so we can very simply then multiply the original generating function by t. We've substituted t cubed where we saw t before, and this is our generating function that we can just write down directly for the discrete random variable 3x plus 1. And that concludes this video. The next video will look at finding mean and variance of a discrete random variable using a generating function.